All right, guys. The next quadrilateral up to bat is rhombus, and the backside we talk about squares. Quick notes, little Pythagorean theorem, and we should be good to go once we talk about the properties. All right, rhombi, which is plural for rhombus. You don't say rhombuses, you just say rhombi. Rhombi have the same properties of parallelograms. Once again, opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles add up to 180. Diagonals bisect each other, and plus 3 more, guys. In this one, for a rhombus, all 4 sides are congruent. All sides, same exact measurement. Diagonals are perpendicular, which means in the middle here, these guys are all going to be 90 degrees for a rhombus. 90 is the middle all the time for a rhombus and a square. Last one, diagonals bisect. This one's kind of neat. Takes away a lot of work. Diagonals bisect opposite angles. In other words, this diagonal right here just cuts the angle in half. So for example, if this angle right here was 10 degrees, this angle right here to be 10 degrees as well. All right, some examples. J to K, 12, which means all sides are 12, right? J to N, this piece is 7, which means that piece is 7 because, remember, the diagonals bisect each other, right? Then we're going to have to use, and remember, these are all 90s in the middle here. Okay, 7, 7. Okay, JM. JM is that piece, 12. J to L, 7 and 7, 14. M to N, all right, Pythagorean theorem, I'll set you up. Highlight the triangle. I know I have a 90 right here. Remember, 90s are all in the middle. So so call this guy X. A squared plus B squared equals C squared. So X squared plus 7 squared equals 12 squared. Subtract 7 squared over. That comes out to be 95. Square root that. 9.7. So M to N, 9.7. And then M to K, the whole thing, right? So if that's 9.7, that piece is 9.7. Add them up, 19.4. Number 2, E to F is 23, which means all sides are 23. Don't forget, we have a 90 in the middle. D to F is 40, so this whole thing is 40. Cut that in half. Each of these have to be 20. Questions, G to F, 23. H to F, 20. G to H, all right, Pythagorean theorem again. Let's make a triangle. Remember, we have a 90 in the middle. We don't know that, call it X. A squared plus B squared equals C squared. X squared plus 20 squared equals 23 squared. Subtract over the 20 squared. Let's see here. 23 squared minus 20 squared comes out to be 12. Square root 12. That comes out to be 3.5. All right, so G to F is 3.5. G to E, the whole thing, 3.5 plus 3.5, 7. Number 3. All right, R to T, this whole thing is 22, which means that's 11. That's 11. U to S is 18, which means that's 9, and that's 9. And don't forget, we always have 90s in the middle with a rhombus. All right, first question, VT, 11. UV, 9. R to S, I don't know, call it X. Once again, Pythagorean theorem, though. There's your triangle. A squared plus B squared equals C squared. So 9 squared plus 11 squared equals C squared. 9 squared plus 11 squared is 202. Square root 14.2. S to T, same thing, right? All sides are congruent, so that's also 14.2. All right, some angles. We can fill these in super fast, guys. Remember, everything in the middle is a 90, so 8 has to be 90. Easiest one to find every single time. Then remember, guys, these diagonals, they bisect the angle. So if that side's 38, that guy's 38, and then both of these are also 38. Now, if I look at, let's say, this triangle at the bottom down here, right? All three angles in a triangle have to add up to 180. So if I take the 90 plus the 38, then subtract from 180, what's left for this guy would be 52, which means he's also 52, which means also 1 and 2 are also 52. That easy, guys. Angles are super easy for squares and a rhombus. Number 5. I'm going to draw another one of these for the angles so we don't get confused. So we'll do one for sides and then one for the angles. All right, sides. Z to Y, 34. W to Y, this whole diagonal is 38. If I cut that in half, each of these would have to be 19. 19, 19. All right, remember 90s in the middle, always. All sides are 34. Let's answer the questions. W to Z, 34. V to Y, 19. Z to V, all right, Pythagorean theorem one more time. Trying to find this piece right here, we'll call it X. A squared, B squared, C squared. We're running out of room here. All right, X squared plus 19 squared equals 34 squared. Subtract the 19 squared over. That comes out to be 795, and then I have to square root that. That comes out to be 28.2. Z to X, the whole thing. Well, if that's 28.2, that has to be 28.2. Add them up, gives you 56.4. Okay, the angles. Angle ZXY, ZXY right here is 34. Let's fill them in. That guy's also 34. He's 34. He's 34. I have all 90s in the middle. Let's go to work. WXZ, WXZ right here, 34. WVZ, WVZ in the middle, 90. ZYW, ZYW right here. We can do this. All three angles add up to 180. Add these two up, subtract from 180, and we got this guy. If you do that correctly, it comes out to be 56. So 56, 56, 56, 56. XYW, XYW right here. Well, that guy also has to be 56. These two are the exact same. These are also 56. Back page. All right, squares. Easy one. A square has all the properties of a parallelogram, rectangle, and rhombus. So it has all the properties we've talked about so far with these three quads are all in squares as well. All right. Just remember, squares also have 90s in the middle. All sides are congruent. And one unique thing, guys, right? I know these corners are 90s in a square, which would mean each of these would have to be 45. All right, let's go to work here. ABC is a square. AD is 11. Find each missing value. All right, first one, BC. Well, all sides are 11, right? So BC is also 11. A to C, this diagonal right here, right? So we got to figure out this piece right here. So Pythagorean theorem. This is my 90. A squared plus B squared equals C squared. 11 squared plus 11 squared is X squared. Add up left side, 242. Square root. That comes out to be 15.6. So A to C, this whole thing is 15.6. BD, well, BD is just the other diagonal. So if this diagonal is 15.6, that guy is 15.6. E to C, just cut that in half. So this whole thing is 15.6. If I divide that by 2, that comes out to be 7.8. So all these little pieces in the middle here, 7.8. Angles, these go fast. DAB. DAB, the whole thing, 90. AEB, AEB, the middle, 90. CBD, just half of the 90, 45. BAC, half of the 90, 45. Number 7. Says we got a square. TR is 17. So all these pieces in the middle are all 17. 17, 17, 17. 90 in the middle, 90 in the corners, right? All right. P to R, the whole thing, 34. Add them up. Q to S, 34. Q to T, 17. P to Q. Well, here we go again. Little Pythagorean theorem. A squared plus B squared equals C squared. We'll call it X. 17 squared plus 17 squared is X squared. Left side adds up to be 578. Square root 24. Angles, super fast. PRS. PRS. Half a 90, 45. STR, the middle, 90. PSR, the whole thing down here, 90. QPR, half a 90, 45. Algebra. Says we got a rhombus, find MP. Well, we know all sides are congruent on a rhombus, set them equal. 9x minus 77 is 3x plus 7. Subtract 3x over. Add 77. Divide by 6. That gives me 14. Then it says find MP. Well, I can plug it back into any of the sides, right? Because I know they're all congruent. So just plug it back in any side you want to. If you do that, it comes out to be 49. So M to P, 49. Number 9, we have a rhombus. Remember, the diagonals cut the corners, the angles in half, right? So these two guys are congruent. Set them equal to each other. 8x minus 20 is 5x plus 1. Subtract 5x over. Add 20 over. And 3 goes in there 7 times. Find angle FED. FED. It wants this whole angle right there, right? Well, here's what I know. Consecutive angles have to add up to 180. So what I'm going to do is I'm going to take the 7, plug it into both of those, and add them up, right? If I do that correctly, this whole angle, angle F, comes out to be 72 degrees. But if I want to find angle E, I got to take the 180 minus the 72 to get angle E. If you do that correctly, E comes out to be 108. That is your answer, 108. Number 10, we have a square. SW is that piece. WU is that piece. Well, I know in a rectangle, or a square, all diagonals are congruent, right? So I'm going to set them equal to each other and solve for x, and then I'll find VT at the end. 2x plus 13 is 8x minus 41. Subtract 2x over, add 41 to the left, divide by 6, gives me 9. Find VT. So VT is this whole diagonal, right? But I know the diagonals in a square are congruent. So I can plug it back into one of these two pieces and just double it, right? So I plug it back into here. That's going to give me 31. But then I have to double that. So if this is 31, that's 31, right? So let's double that. 31 times 2, 62. So V to T, 62. Number 11 says we got a square, solve for x. Well, if this is a square, this corner is 90, right? So this 40, we have a 45 there and a 45 there. So that guy is equal to 45 degrees. 7x plus 3 is 45. Subtract 3. Divide by 7. X is 6. Found x. We are done. That's it for rhombi and squares.